ahead and look at this one, and this is question 89 on page 166. And what we've got is we've got x to the fourth plus 2x squared minus 15 now equals 0. Now we're going to factor this just like this was just an x squared and an x. So first times the last, there's no number here, so we take 1 times negative 15. That makes it then negative 15. And what two numbers would multiply together to give you 15? Subtract from each other to give you a 2 in the middle. You want to tell me what those two numbers would be? Yep, 5 and 3. Middle is positive, so we'll use a 5 and a minus 3. Now, the only difference when we go to factor this is instead of it being an x down here, it's going to be an x squared, because we split this x to the fourth in half. So that's going to be x squared plus 5 and x squared minus 3. So that's our only difference because it was an x to the fourth. So when we factor it, it becomes an x squared. Next, we're going to solve each of these. So we're going to go ahead and solve each one of these. So we're going to begin by solving x squared plus 5 equals 0. So move that 5 over. So x squared equals a negative 5. Now let's remember, this is an x squared now, not just an x. So how do we get rid of a square? We take a square what? Root. Okay? And whenever we take a square root, what do we add on? Plus or minus, don't we? And what does that leave you with? Well, that leaves you now with x equals plus or minus. Now it is negative underneath our square root. So because it's negative, we bring out an I. Right? And then the 5 is left underneath the radical. So that would be plus or minus I square root of 5. And that means we actually have two solutions. So we actually have I squared of 5. Right? We also have minus I squared of 5, because there's both of them. And now let's do the other side. So now let's solve the other one, which was x squared minus 3 equals 0. So we'll add our 3. And how do we get rid of a square? We use a square root, just like we've done numerous times before. And add on your plus or minus. So that gives us then x equals now plus or minus the square root of 3. And what would we have for our solutions? Square root of 3 and minus the square root of 3. There is our 4 solutions, 2 from each one. So 4 solutions in total. Now we're going to look at how to solve some applications. And these are actually very, very easy to set up. There's not much to these, but these make fractions that we then clear out and that we then solve. So let's look on page, and we'll do two of these, 165. We're going to look at question 37. Now these, all we have to look at is how much of it is done. It's a work problem, and work problems we look at what proportion is done. So these are going to be things like cleaning a house, painting a house, mowing a lawn, maybe filing someone's taxes, anything that takes time and work. Now, when you have two people working together, they add. Or it could be if you're filling up a pool, you can be adding and also draining at the same time. So it could be a plus and a minus. But what we look at for each one of these is we look at how much each person, or in case of water, how much is going in and out, how much is done per hour. What portion of the house is going to be done, in this case, per hour. So, Joe can paint a house in 3 hours. Sam can paint the same house in 5 hours. How long does it take them working together? Well, obviously, we wouldn't just add them together, because if we just added them together, we would get 8, right? And we've got Sam, who can do the house by himself in 5. So if I add and get 8, that doesn't make sense, because obviously Sam does it by himself in less time. So what we have to look at is we have to look at how much of it is done per hour. What fractional part is done per hour? So when we look at Joe, okay, Joe, it takes him 3 hours to paint this house. So how much is done in 1 hour? If he takes him 3 hours to paint the house, in 1 hour, he has painted a third of that house. What about Sam? Sam's a little bit slower. Sam paints this house in 5 hours. And so that means how much does Sam do in an hour? He does 1/5 of the house. And obviously these are working together. And so if they work together, that means they add. Now, X is going to represent the time. So let's talk about Joe. How much of the house does Joe paint in an hour? He paints a third. How much time does it take him? Unknown amount of time, X. Sam is going to help him paint this house. Sam does in 1 hour 1/5. How long does it take him? We don't know, so we use an X. They're always going to equal 1 because that is 100%, right? We paint one house or 100%. So we just make them fractions like this. We're going to clear them out and solve this. Well, easy enough. There's nothing to really do. Common denominator here, we have a 3 and a 5. So least common denominator would be a 15. So we multiply everything by 15, and then we distribute through. So 15 divided by 3 is a 5x. 15 divided by 15 divided by 5 is a 3x. And 5 times 1 is a 15. Add them together. That's 8x equals 15. Okay. Divide by your 8. And so x equals 15 over 8. Now, let's see if that makes sense. What do we know about 15 over 8 as a decimal? Okay, so let's see. 15 divided by 8. 15 divided by 8 is 1.875, which is about 2 hours. Now, does that make sense? Yes. Why? Well, if Joe can paint this house in 3 hours and he has a helper, then it should be less than 3, right? Joe does it by himself in 3 hours. So if he has a helper, it's going to take less than 3 hours. And obviously that 1.875 is less than 3. So we know it looks correct. But that's how you look at it. Let's do a subtraction one. And then that'll be it for this section. So let's look at 43. This one's a subtraction question. With both taps open, Robert can fill a kitchen sink in 5 minutes. When full, the sink drains in 10. How long will it take to fill up the sink if Robert forgets to put in the stopper? Now, if it only takes him 5 minutes to fill and 10 minutes to drain, eventually this is going to overflow. It'll take time, but it will overflow because it's coming in faster than it's going out. So we've got a kitchen sink. We've got water going in and water going down the drain. Now, going in is going to be positive. Coming out is going to be negative. So we've got the kitchen sink. Both taps are open, and it fills in 5 minutes, which is then 1/5 of the sink in 1 minute, because we have to look at it in terms of 1 minute in this case. The last one was hours. This one is in minutes. So in 1 minute, we do 1/5, and that's positive. We're also draining, and it takes 10 minutes to drain. And so 10 minutes of drain then would be minus 1/5. Because this is minus here, and that's why it's going to be minus. Now again, X is going to represent the time it takes to fill up the sink. We're going to put them together. So we've got fill, and we've got the drain. How long does it take him to fill? In 1 minute, how much is done? 1/5. So that's 1/5 X. Then we've got 10 minutes here. That's a minus 1/10, right? Because we're draining out. So that's minus 1/10 X. And what does it always equal? 1. Why 1? Because that's one sink. All of these equal 1. Clear this out by multiplying by 10. Ten divided by 5 is a 2x there. 10 divided by 10 goes away. That makes it a minus x. And 10 times 1 makes it a 10. Adding those together, we then get x equals 10. And so it fills up that sink in 10 minutes. That makes sense because if we put the stopper in, it only takes 5 minutes to fill. Now, if we pull the drain plug out, it's eventually going to fill up. But it's not going to fill up in 5 minutes. It's going to take longer. In this case, it takes 10 minutes to fill. So that would be your answer there, 10 minutes. These applications are very, very simple. They're much easier than the ones out of 1-5. We do have some time left, so now we're going to look at inequalities quickly. So now we're going to move on to 1-7. We're not going to finish 1-7, but we're going to at least try to make a dent in 1-7. And this is easier. It's inequalities. And when we look at these inequalities, we're going to look at linear ones first, and we're going to have to remember how we graph them and put things on a number line. So 1-7 is inequalities. And when we talk about inequalities, we're going to be graphing them. And we've got greater than or less than. Remember, those get parentheses. Greater than or equal to, less than or equal to, those get the brackets. And then what about positive or negative infinity? Positive or negative infinity, it also gets parentheses, right? Remember that? Okay. Now the ones we're going to look at right now are going to be linear. So we just solve them like we always would. We graph them on the number line, and that'll give you your answer. So these are not going to be that complicated. We will look at a few quadratics, but most of that we're going to save for next time. But let's talk about linear inequalities. So let's look at a linear inequality. Now also we need to remember too, what about inequalities? When you divide, when dividing by a negative, because that's usually what you do, what happens to the inequality? Remember, when you divide by a negative, you flip the inequality. Just want to make sure we remember that rule. So when we divide by a negative number, that's going to end up making us flip that inequality symbol. Right? So we reverse it. Reverse the direction. You've done these before. You've done these in elementary algebra. You did these in intermediate algebra. We're going to do them again in college algebra. And let's look at one of these that's linear. We'll just do one with fractions. That way it's not too easy. All right, so we want to solve this. This is a linear inequality. Now we solve it like it's an equal sign. Only difference is, when we get to the end, we put it on a number line. And so we're going to start by clearing out our fractions. So we've got a 3 and we've got a 4. Least common denominator, 3 and 4, is of course 12. So we're going to have to multiply everything by 12. Okay, nothing new. And we just distribute through. So 12 times 5, that's going to make it then a 60x. 12 divided by 3 is a 4. 4 times a negative 2 is a negative 8. Inequality stays the same. 12 times 8, that should be a 96. So 12 times 8 is a 96. And it's a negative. And then 12 divided by 4 is a 3. 3 times 1 makes it a 3x. Now we just solve it. So move that 3x over and add the 8. 60 minus 3 makes it a 57x. Inequality stays the same. 96, that's negative, plus a positive 8. That makes it a 96 minus 8. That makes it a negative 88. Divide by our 57. Do we flip our inequality? Yes or no? No. Why not? We didn't divide by a negative, did we? Okay. How do we write our answer? Interval notation. We need a negative 88 over 57. We want a square bracket. Which way does it point? Right? It points back to the left. So we need a square bracket. And it's going to go back to the left because that's the way that it points. And when it goes back to the left, that's going back to negative infinity. And so our answer then, in terms of interval notation, is going to be negative infinity, working from left to right, comma, negative 88 over 57 with a square bracket. Now let's do another one. Okay. We'll try to do a couple more of these. I'll have it posted online so you can see it also. So. Yep, I will see you on Wednesday. We'll do a couple more of these, and then we'll look at a 3-part, and then we'll look at a quadratic. So we're going to go ahead and solve this. And I'll try to make one like what you got in your homework here. About x plus 1 over 3 is less than x minus 2 over 5 plus 2 over 15. And this is going to look very, very similar to question 1. A little bit different, but pretty much the same. Well, what are we going to do here? Well, we need to clear our fractions, so we're going to go ahead and break this up. We're going to break it up into individual fractions so that it's easier to deal with and handle. And once we're at this step, we need to clear our fractions, and so we're going to multiply it all by 15, because 15 will take care of all of our fractions. And so 15 divided by 3, well, 15 divided by 3 is a 5, so that's a 5x. 15 divided by 3 is a 5, times 1, that makes it a 5. Inequality stays the same. 15 divided by 5 is a 3x. Right? 15 divided by 5 is a 3, times a negative 2, makes it then a negative 6. Let's make sure we did that correctly. Yep, 3 times negative 2 makes it negative 6. 15's cancel, that leaves you with a positive 2. And we'll go ahead and clean this up a little bit. So now we've got 5x plus 5 is less than 3x minus 4. And we should know what to do from here, right? Move it over, and we're finished. So move that 3x over, and move that 5 over. And now we've got 2x is less than a negative 9. We divide by our 2. And that leaves us then with x being less than negative 9/2. And I know we're going through this one pretty quickly, but you should have seen these before. I know we have done these numerous times. Now, we're not done yet, because this needs to go on our number line. And here is our negative 9 over 2. And again, which way does it point? It points back to the left. And it has a strictly less than, so we use parentheses here. Goes back, and goes back to negative infinity. So what does our answer then look like? In interval notation, it looks like negative infinity, comma, negative 9 over 2. Let's do a 3-part inequality. And see how these work. So this is what's called a 3-part inequality, sometimes called a double inequality, because you've got 2 of them. And so what we're going to do is we're going to clear out that fraction. Now, we're going to have to multiply by a negative. And when you multiply or you divide, normally it's divide, but whenever you multiply or you divide by a negative in an inequality, that changes your signs of the inequality symbol. So it's going to flip them. So Negative 3 times negative 1. Negative and negative makes it a positive 3. We flip our inequality symbol. The negative 3's cancel, so that leaves you with an x minus 5, because those cancel directly. We flip our inequality symbol. Negative 3 times positive 9 is a negative 27. We add our 5's. And that's going to make it a negative 22 there. Positive 8 on the left, negative 22 on the right. When we place these on the number line, we need to make sure that we put them in the correct order. And we flipped our symbols, so that means we have to flip how they go on the number line as well. Negative 22 is the smaller of the numbers, so it's going on the left. 8 is going on the right. And we need square brackets for both of these. And it's going to be in the middle. And so then what does that look like in interval notation? Well, it looks like minus 22, comma 8 with the square bracket. Now for quadratics, when we work these out, they're going to be worked the same way. But when we have quadratics, when you have any squares or anything like that, we have to check regions, because these are going to build regions. And what you do is you check each region. So for quadratic, or nonlinear, inequalities, you're going to have to check the regions. And what we do to solve these is, again, they have steps. We have to check our regions, and here's our steps. For step number 1, we replace the inequality with an equal sign. So we're going to replace that inequality with an equal sign. And then step number 2 is we factor if we need to, and set to 0. Then we solve. And then we make regions and shade the true regions. Okay, there's 3 of them in your homework. So I'm going to do one like each one of these. Now, sometimes they're already factored, and they're already set to 0, and that's nice. So this one's already been factored and already set to 0. So this is a quadratic or a nonlinear inequality, right? It's already been factored for you. The next ones won't be factored, but this one's already been factored. We've got our groupings, right? And they've been factored out. Now, when we solve them, these are going to be called my critical points. So when we get our answers, these are not our actual answers because they've got to go back on the number line. These are called the critical points. And critical points are just what goes on the number line. Okay, so these critical points, well, they go on the number line. So we replace it with an equal sign. So that's what we do first, is we replace our inequality with an equal sign. All right. And now we're going to go ahead and get our critical points. So we've got 3 of them in this case. So x minus 8 equals 0. So one of them is x equals 8. X plus 4 equals 0. So x equals negative 4. X minus 2 equals 0. So x equals 2. Now the only difference between this one and the linear ones that we did a moment ago is the fact that these have to be put on a number line, and then you have to check it back in the original to see if it's true or if it's false. Because that's all we care about, is if it's true or if it's false. So we put these back on our number line, and we put them in the correct order on the number line. And so we've got a minus 4. We've got a positive 2. And we've got a positive 8. And we think about these as like cuts on the number line. So they make different regions. And if we work from left to right, we actually have 4 regions. One more, then you have points. So we actually have 4 regions here. These are our regions. And what we do is we need to see if the region as a whole is true or if that region is false. And we do that by picking a point and plugging it back into the original. So we pick a point that is clearly in each region, and then we check it in the original. And we see if it comes out to be a true statement or a false statement. Now, we want to pick as small numbers as possible, and whole numbers if possible as well. So we're going to start with region number 1. Okay. Now region number 1 is for numbers that are smaller, right, because it's back this direction, smaller than negative 4. So we need the next smaller number would be negative 5. And then we need a number between, for region 2, we need a number between 2 and negative 4. Well, an easy one to pick, if possible, is going to be 0. Because 0 is in between them. And then we look at 2 and 8. Well, number between 2 and 8, make it easy. How about 3? 3's in there. And then a number bigger than 8, how about a 9? And we're going to check each region back in the original. Before we factored it, before we did anything else, back in the original. So we're going to check in this. We're going to check them back in x minus 8, x plus 4, x minus 2 is less than or equal to 0. So we're going to check it back in this. And we're going to start with region number 1. So we're going to plug in a negative 5. So minus 5 minus 8, minus 5 plus 4, and minus 5 minus 2. And we're going to see if this is true or false. So we plug each number back in, and then we label it with the T or an F, depending upon what it is. So minus 8, minus 5. Now, we really don't have to actually come up with the actual number. All we care about is the sign. Because we're looking to make sure that these numbers are less than 0. That's going to make it true. So minus 8 minus 5, that's negative. Minus 5 plus 4. Okay, minus 5 plus 4 is a negative 1, so it's negative. Minus 5 minus 2 is negative. 3 negatives make it a negative. Now, all we have to do is say if this is true or false. Are negative numbers smaller than 0? Yes. We could get the actual numbers here, but it really doesn't matter because all we need to check to see is if it's positive or negative at the end and whether it's true or false. So in this case, we got negative numbers smaller than 0. Are negative numbers smaller than 0? Yes, they are. So that would make this region then true. Second region, we're going to plug in 0. 0 minus 8, 0 plus 4, 0 minus 2. 0 minus 8, negative. 0 plus 4, positive. 0 minus 2, negative. 2 negatives make it positive. Are positive numbers smaller than 0? Are positive numbers smaller than 0? No. So that means this one would be false. Most of the time they're going to switch back and forth between true and false. So we've got 2 more to check. So let's check 3. 3 minus 8. 3 plus 4. 3 minus 2. 3 minus 8, single negative, right? 3 plus 4, positive. 3 minus 2, positive. 1 negative makes it negative, and our negative numbers less than or equal to 0. Is that true or is that false now? Okay, that would be true. And one more, we'll pick the 9. And when we pick the 9, we've got 9 minus 8, 9 plus 4, and 9 minus 2. 9 minus 8, well, 9 minus 8 is 1. 9 plus 4, okay, 9 plus 4, and we don't even care about the number. All we care about is the plus because 9 minus 8 is 1. 9 plus 4, positive. 9 minus 2, positive. All positives stay positive. Are positive numbers smaller than 0? No. Okay, now what do? We've got it all labeled, true and false here. So we go back up and we shade where it's true. So it's true here, and it's true in here. We have a less than or equal to, so that's why we're going to use square brackets. And then what does my answer look like? Well, our answer in interval notation is going to look like negative infinity, comma, negative 4, with the square bracket, U for union, 2 to 8, also with a square bracket. Okay. And that's your answer. Let's do one more of these because I think we've got enough time to do one more. This one will actually be a little bit quicker. This one's going to be a factoring one. Again. And I'm going to make it look like your homework. So we're going to look at this one. And this, of course, has powers on it, and we're going to have to be factoring. So I'm going to move that 3x squared over. And that leaves you then with 3x cubed minus 3x squared is less than or equal to 0. And I'm going to box this because this is what I'm going to be checking it in. Okay, I can check it here. When it's equal to 0, that's going to be the easiest one to check it. So this is what we're going to use to check. So we're going to be using that to check. Now what we have to do is we have to factor this. We replace that inequality with an equality. And then we can factor this. Now this one should be very easy to factor. Well, looks like we've got an x cubed and we've got an x squared. So I'm going to factor out an x squared. And that's going to leave me with an x minus 3. And we're going to get our two solutions because we know that x squared equals 0, so x equals 0, right? And the other one is x minus 3 equals 0, so moving it over, we get x equals 3. Okay, so easy enough there. Now, these have to go on our number line, just like we did in the previous problem. 0 and 3. And we make our regions. Regions 1, 2, and 3. And we need numbers to check. So we need a number less than 0. So how about we check with a negative 1, because that's less than 0. Between 0 and 3, so how about 1? Larger than 3, how about 4? Okay, so what are my answers now? What are we going to have to check? We're going to check each one. We're going to use this to check. So let's check each one. And we'll start with negative 1. And we're going to check it in x cubed minus 3x squared is less than or equal to 0. So if I plug my negative 1 in, and this one we're actually going to have to work out because it's going to require us to actually plug it in and check values. Okay, if I plug in a negative 1, negative 1 when we cube. When we cube a negative, remember it stays negative. What about the next one? Okay, negative 1 squared makes it positive 1. Positive 1 times a negative 3 makes it still a negative 3. And minus 1 minus 3 makes it a minus 4. And is minus 4, is that going to be less than 0? Is minus 4 less than 0? Yes, it is. So that means that piece is true. So we label that one as true. Then we plug in 1. And we've got, when you check it, we've got 1 cubed minus 3 times 1 squared. And we know 1 cubed is 1. 1 squared is 1 times negative 3 makes it a negative 3. And 1 minus 3. 1 minus 3 makes that then a minus 2. And is minus 2 smaller than 0? It still is. Most of the time they switch back and forth, but not all the time. Especially when you take out an x squared. When you take out an x squared, they may not all switch back and forth at the same time. So you always want to check all 3 regions, or 4, or however many you have. Now let's check x equals 4 and see what happens with it. Okay, so we've got 4 cubed minus 3 times 4 squared. And that's supposed to be less than 0. Well, 4 cubed is 4 times 4 times 4. And so 4 cubed is 64. 4 squared is 16. Times a negative 3, that makes it a minus 48. And 64 minus 48, that's 16. And 16 is not smaller than 0, so that piece is false. Now we shade where it's true. And where is it true? True in those regions. Okay. It's going back to negative infinity. So what does my answer look like now? In interval notation, negative infinity on the left. Where does it go to? It goes past 0. It goes all the way to 3 with the square bracket. So there is your solution. Now, it might have been false, false, and then true. In that case, would be this piece here. But hopefully that gets you through some of the questions. And now we're going to talk about what we've covered for the homework. So what you should be able to do for your homework is 1.6. You should be able to do them all. Okay, so you should be able to do every single one out of 1.6. Now, 1.7, you can do most of them. You can do 1, because we did one like that. You can do question 2. You can do question 10. And then 11 through 15. So 11, 12, 13, 14, and 15. So you should be able to do all of those from your homework.